go ahead and pause the video and try the warm-up. So you're going to use the graph to answer all of those questions. So hopefully this is what you came up with. Remember, domain deals with your x values. So it looks like because there's an arrow on the left and there's a closed dot on the right, domain goes from -infinity to 6, but 6 is included. Range is dealing with the y values. Arrow on the left indicates that it'll keep going down, so -infinity up until 1, which is included because that's the highest and it is a part of the graph. I have a couple of zeros, so notice that where the graph touches the x-axis is at both a -3 and a +3. F of 0, so where is my function at 0 for x? Well, that's at +1 for y. Intervals, remember, are always closed, so I want parentheses around them. It increases from -infinity to -2, decreases from 2 to 6, and it has a constant interval from -2 to 2. The values of x for which f of x equals -2, well, if I look, there are a couple of spots where we have that y value. It's at -5 and at +5. And then it asks, is f of 2 a relative maximum? And my answer is no, because if you're looking, it's a part of a constant slope, which tells me that it's not going to be the highest at that point surrounded by all the other points, because some of the points on the left are the same height. All right, so we are going to continue with section 2.4, more on slope. Today we're going to find a function's average rate of change, and we're going to create functions that model real-world applications. So, slope is rate of change. Slope is defined as a ratio of a change in y to a corresponding change in x. It describes how fast y is changing in respect to x. Okay? I mean, we've been calculating slope now for quite a while. So, average rate of change is essentially the same idea as slope. Okay? However, it doesn't have to deal with straight lines. So if a graph is not a straight line, the average rate of change between any 2 points is the slope of the line containing the 2 points. And this is called a secant line. You've probably heard of secant lines, maybe last year in geometry. So let's look at this equation for average rate of change. So it says, let the ordered pair x1 f of x1 and the ordered pair x2 f of x2 be distinct points on the graph of a function f. So the average rate of change of f from x1 to x2 is the following: f of x2 minus f of x1 all over x2 minus x1. So essentially it is exactly how we calculate slope, because remember, f of x2 and f of x1 are the y values. I'm subtracting the y values on the top, and then I'm subtracting the corresponding x values on the bottom. So I am doing slope. The only difference is that because it's in function notation, we might have to do a little bit of calculation to find that value first, but then essentially we are just calculating slope. Notice how the secant line is going to touch it and cross through it, okay, at two spots there. All right, so it says find the average rate of change of f of x equals x cubed, and then they're giving us two values. So notice that they're not giving us ordered pairs, so we're not able to calculate the slope right away. But because they gave me x1 and x2, we can find what f of x1 and f of x2 is by just evaluating. So f of x1, which essentially is f of 0, I'm going to substitute 0 into the function. Well, that means I'm cubing 0, and when I cube 0, I get 0. So essentially then, 0, 0 is my first ordered pair. I can also evaluate and find f of x of 2. X of 2 is 1, or x2 is 1. So I'm finding f of 1. So I'm going to substitute 1 into my function. So 1 cubed is going to give me 1. So that means that the ordered pair 1, 1 is what I want to use. So now I've got my x1, y1, and x2, y2. I'm essentially just doing slope. And I just replace the f of x1 and the f of x2 with x1 and y2. Okay, so I'm going to subtract. The y's go on the top. and then the corresponding x's go on the bottom, well, that turns into then our rate of change being 1. Same idea then in part B, but now I want to go from x1, which is 1, to x2, which is 2. So f of x1 means that I want to find f of 1. We're using the same function, so I'm cubing 1, and cubing 1 results in 1. So we're using that ordered pair 1, 1. If I'm talking about finding the function at x2, but x2 is the number 2, I'm substituting 2 into that function. Well, 2 cubed is 8. So we are dealing with the ordered pair 2, 8. And now I'm just doing slope with the 2 ordered pairs that we have. So 8 minus 1 all over 2 minus 1. 8 minus 1 is 7. 2 minus 1 is 1. So that tells us that our average rate of change is 7. Okay, let's look at a different function and do more average rate of change. So I want to evaluate f of x of 1, and so that gives us f of negative 1, which is what we want to evaluate. So I substitute negative 1 in wherever I see an x. So we'll have negative 3 times negative 1 quantity squared plus 2. Well, negative 1 quantity squared is positive 1. Negative 3 times 1 is negative 3, and if I add 2 onto it, I'm going to get negative 1. So it looks like one of my ordered pairs is negative 1, negative 1. If I evaluate the function at x2, which x2 is the number 4, we'll have negative 3 times 4 quantity squared plus 2. Well, 4 squared is 16. So negative 3 times 16, then I want to add 2. That's going to give me negative 48 plus 2, so I get negative 46. So my ordered pair is 4, negative 46. So now that I have those 2 ordered pairs, I'm just going to calculate the slope. So we've got negative 46 minus 1 all over 4. Minus a negative 1, so that'll be positive. And then 4 minus negative 1, so 4 plus 1. So negative 46 plus 1 is negative 45. 4 plus 1 is 5. And notice that this then will simplify into negative 9. In the next one, we want to find what my function would be at 0. So we'll have negative 3 times 0 squared plus 2. Anything times 0 is 0. And so then 0 plus 2 tells us 2. So our first ordered pair is 0, 2. Then I want to find what x2 is in for that. So I want the function at 5. So we'll have negative 3 times 5 squared plus 2. Well, 5 squared is 25. Negative 3 times 25 is negative 75. When I add 2 onto that, I'm going to get negative 73. So I'm dealing with an ordered pair of 5, negative 73. So now I can use those 2 ordered pairs to calculate my slope. So we'll have negative 73 minus 2 on the top. Those are my y's, all over 5 minus 0 on the bottom. So we'll get negative 75 on the top, positive 5 on the bottom. Divide that, and our average rate of change is negative 15. Okay, so go ahead, and here I'm giving you the function f of x equals negative x plus 7, and I want you to find the average rate of change going from negative 9 to 10. Okay, so I evaluated each of those and then found my ordered pairs. I then went ahead and did my slope, and I got negative 1. All right, let's look at some application problems. It says in 1995, the average U.S. consumer spent $35 on video games, and this amount has increased at an average rate of $4 per year since then. We want to write a linear function in slope-intercept form that models this data. Okay, we've already done stuff like this, but once again, slope-intercept form, y equals mx plus b. Based off the information, we want to know what was my slope and what was my y-intercept. So since they're talking $4 per year, that's the constant rate, so that is my slope. Because it's an increase, I know that I want to keep it a positive, so y equals 4x. Notice that my starting consumer spent $35, so that is my y-intercept. And there is my equation that models the data. If I write it as a linear function, though, we'll write it in f of x terms, so 4x plus 35. So f of x equals. So just get in the habit of doing f of x if it's talking about a linear function. So go ahead and find the linear function in slope-intercept form that models this. So hopefully we noticed that they're spending $4,700, but we're decreasing at an average rate of 156. So I needed to have my slope be negative, so negative 156x plus that 4,700, but notice f of x equals. That's us finding the function's average rate of change as well as creating functions that model real-world applications.